In our last lesson, we got our collision detection working, so we can now shoot asteroids. But in the real game, once we hit an asteroid, it breaks apart into smaller pieces. We need to be able to scale our vector graphics so we can generate different sized asteroids. So let's code it. Hi and welcome to Bytes and Bits. I'm Bob Grant and this is lesson 5 in my Asteroids programming course. In the last lesson we managed to get our polygon collision detection working so that we can now shoot the asteroids. But at the moment we simply kill the asteroid and remove it from the screen. We now need to explode the large asteroids into two medium-sized ones, and then explode medium-sized asteroids into two small asteroids. And then finally, these small asteroids are the ones that get destroyed. So we're going to be looking at dynamically creating new asteroids and working out how to scale our vector graphics to create these multiple sizes. So let's get straight into the code. In our code then, we have an area or a function which actually explodes our asteroids for us. So if we go down there, we'll see at the moment, this is called when we detect that one of our bullets has hit an asteroid. So we call this function, and this function is passed in the index of the asteroid that has been hit in our asteroids array. And we simply then do this removal. So we need to modify this function then to actually take this existing asteroid out and replace it with then two new asteroids. Now in our code, we already have a function which allows us to generate some asteroids. So if we go to our function generate asteroids, we'll see in here, this is where we generate the asteroids at the beginning of the game. But this idea of counting up how many asteroids we want to create, spawning the asteroid and then adjusting its values to set it up correctly, that's exactly what we want to do when we explode an asteroid. So this function then, so our new explode asteroid function is going to be some variation of generate asteroids with then the idea of removing the existing one. So I'm going to leave that for you to have a go at. So I'll give you the 5-second countdown and then come back and show you my solution. Okay, so really the only function that we need to modify is this explode asteroid function. So again, the initial one was simply the idea of taking the asteroid out of the table. But now we need to generate two asteroids. But we need to generate these asteroids in the same position as the old asteroid. So what I'm doing first of all here, I am grabbing a copy of the position object. So again, remember, asteroid itself is our local variable coming in, which is the actual asteroid we're working with. Index is the index of it in our asteroids array. So I'm looking at my current asteroid and its position object, and I'm just making a local note of that. I'm then doing my removal, so that gets rid of the old asteroid. And then we need to generate our two new asteroids. And this for loop is exactly the same as we saw in our generate asteroids function. So again, I need to create a local variable. I then need to do my count. So I'm going to count from 1 to 2. So that'll give me 2 asteroids. I'm spawning my asteroid. I'm then setting its velocity and its rotation to random values. And again, we've been through that already. But what we now need to do is we now need to set its position. And the position, of course, then is going to be the same as the previous asteroid's position. So our new asteroid's position is set equal to that local copy that we made. So remember, we made a local copy up here. We did local position. And then we then insert that asteroid into the asteroids table. And that's really it. So if we run that then, come in here, we should now find that if we were to shoot an asteroid, it now breaks up into 2 separate asteroids, and each of those then becomes its own separate object and goes off and now becomes part of our game. So back into our code. So we've now got our code generating the 2 asteroids to replace the old asteroid, but they're currently being generated at the same size. So we need to work on our scaling. So if we have a look at our spawn asteroid function and go to spawn asteroid. Okay. So we're coming in here and we are setting everything up, and this is the place where we now generate our points system. So each of these points then is going to be one of the corners of our asteroid, and we know that that is controlled by this idea of the asteroid radius and so on. So our first point then is directly horizontally to the right of our asteroid center, and we set that then to our asteroid radius. We then go through, and remember we step round in a number of segments. So each segment we're treating as a little vector, so it gives us an angle and a distance from the center point. And this is where we create the radius of our of this particular point, and we have the actual angle of our point. So we create a vector. So remember we initially had set all our vectors to be for speeds. So the speed then is the magnitude of it, which we set to the radius. The direction then is the angle, and we then work out the components to get us back into x, y coordinates. And at that point we have the values we need to then add a new point into our asteroid shape. So we have our x and our y components. So if we want to scale this asteroid, really all we need to do is, at this point here, is when we get our radius of our asteroid, we really just want to scale that down. So we need a way of telling our spawn asteroid function what scale factor to apply to this particular asteroid. So we can do that by supplying a parameter to the function. So we're going to call our function to spawn an asteroid, but we're going to tell the function what scale we want to set this asteroid at. And once we've done that, all we need to do now is anywhere where we are setting a radius, we simply need to divide. Because again, I'm going to say this is going to be my division factor. So 1 will give us a full-sized asteroid, 2 will give us a half-size asteroid, and 4 will give us a quarter-size asteroid. So I'm simply going to divide my distances by that. So I just need to divide that then by scale. And when I come in here, when I get my radius, so radius is math.random of that stuff there, and I'm just going to divide that by scale. And then when we come down here, we do our last point. So our last point is here, and that's again we need to divide that by our scale factor. And that should now let us generate an asteroid of different sizes. So we of course now need to, because our function call now has got this extra parameter coming into it, we now need to, anywhere where we're calling spawn asteroid, we now need to supply this scale. So if we come down here to our generate asteroids, this is where we're generating them at the very start of our code. So that wants to have a scale value of 1, because these are going to be full-sized asteroids. And then the last bit we did then was our explode asteroids. And this is now where we want to set a scale factor here. So just to make sure that everything's working, we'll start off by just coming in here and setting our scale factor equal to 2. So that should, when we hit an asteroid, that should make our asteroids half size. So let's have a go at that and see if that works. So come in here, and now if I hit that asteroid, we should get 2 half-size asteroids. And that works there. Okay. But what we now need is if we shoot one of our half-size asteroids, we now need that not breaking up into two more half-size asteroids, but breaking up into quarter-sized asteroids. So let's come back in here to our code. In our explode asteroid function then, it's going to need to have some sort of record of what size the asteroid is. So when we generate our asteroid, we pass in a scale, but at the moment we're not storing that value anywhere. So we don't know what size this asteroid was created at. So of course we're going to need to add that into the asteroid's attributes. So let's code that in here and say that when we spawn an asteroid and we have a scale value, we're going to store that value in our asteroid in an attribute called scale. So then anytime we call up this asteroid and use this asteroid, we'll be able to have a look at this attribute, and that will tell us what scale this asteroid is set to. So if we go back to our explode asteroid function, we now know that we have an asteroid coming in here, and so at this point here, asteroid is the asteroid we are currently exploding. So let's collect that. So let's call this original scale, and we're going to set that to asteroid.scale. So we've now grabbed the position of the original asteroid and the scale of the original asteroid. So what we need to do down here is we need to now work out the asteroids that are being exploded from this one, what size do they need to be? So we can really say, so local new scale, and that really just needs to be our original scale times 2. So what that's saying then is if we had a scale 1 asteroid that's been exploded, then our new scale is going to be 2. If we have an asteroid whose scale was 2, then it's going to be 4. So we're always halving the side of our asteroid. So when we then spawn a new asteroid, at that point we want to set it to the new scale value. So this should now, every time we hit the asteroid, it should halve in size. So let's just test that out and see what happens. So if I shoot an asteroid, we get that, then we get quarter-sized ones, and this at the moment, our code will just carry on going down, and if I can even hit that one, again, once we get the small ones, it's very, very hard to hit, obviously. But that should, if I can hit it, maybe not. There we go. We can see now that we're getting smaller and smaller and smaller asteroids. Now this of course isn't exactly how the game works. The game allows you to shoot bigger asteroids, they break once, twice, and then they disappear. So let's see if we can get that built into our system now. When we come into our explode asteroid function then, at this point we know what scale factor that this exploding asteroid is. And at that point we need to take it out of our system. And that's when we then decide, at this point here we'll need to decide whether we need to generate new asteroids or not. So we'll put in our if statement. So if our original scale is less than 4, so remember, asteroids which are size 1 or size 2, they're the ones that need to be exploded. So if it's less than 4, then we need to do all of this stuff here. So let me just tab that out for you. So keep it all lined up. That's the end of our for loop. And that is the end of our if loop, if function. So we come in to explode the asteroid. we take out the existing asteroid. If it was either full size or half size, then we break it apart and make 2 more new ones. Otherwise, we just don't have to do anything because we've just removed it and that should now be gone. So let's run that and see what happens. So I come in here, so break it apart once, twice, and these ones should now, if I can hit them, disappear. So we've now got our asteroids all doing the correct explosions. So that's all seems to be working okay. So let's come back into our code. So to finish off this explode asteroid function then, we really need to start putting in some sort of scoring system and also make some sort of sound then when the asteroid gets exploded. So why don't you have a go at adding that in? So again, I'm just going to, on mine, I'm going to put a score in and have the score up here. I'm going to do different scores then depending on the asteroid size. I think I'm probably going to have 50 points for a big asteroid, then 100 and 200 for the other asteroid sizes. I'm just going to display it then, say in the top left corner, and then I'll make a sound and add that in as well. So see you in a few seconds. Okay, so in my explode asteroid function then, I've created a global variable called player score, which I'm simply updating here then. So again, 50 is my base score for an asteroid. And then depending on this idea of the scale, so remember the scale goes from 1 to 2 to 4. So that just gives me a very easy way of getting more points for the smaller asteroids. And then I've got my sound effect. So if I go to my sound effects, I've created a sound effect then in index number 1. And if I look at this then, so it's using the white noise generator, which gives us sort of the explosion effects. It's coming high volume to begin with and then fading away, and not doing very much then on the arpeggio and the pitch. So if I play that, I get that sort of nice sort of explosion effect. And then coming back in here, so once I get the asteroid being exploded, I just generate this sound effect then. And again, any of these commands, if you're not quite sure what they are, you can go to the documentation pages for TIC80. So if you go to github.nestbox TIC80 and then wiki, it'll take you into the main documentation for this, and you'll be able to see, if we look down the side here, you can see all the various TIC80 specific commands. So obviously TIC80 is built on Lua, so you need to look up the Lua documentation for actual Lua commands. But all of these commands here are the special ones which are part of TIC80 to get TIC80 working. And you can see there's quite a few things that we haven't covered yet. But the sound effects one then, you can see here, it tells you what the structure of it is. So ID is the ID number when you design the sound. Note then is the pitch that you want to play it at, and so on. You can see there's a number of different effects that you can have in there. But if we come back to our code then, so we're making a sound effect with our sound number 1, a very low pitch, and then the 50 duration. And that then gives us our explosion effect. But what I've done a little bit differently then is on the player score side, we need to get that displayed on the screen. So if I come up to the top of the code here, so you'll see that I have created my global variable player score. And as we come down here, we have our game entering a number of states. So our start screen, which is done here, it waits for us to press the fire button and then goes to init game. And init game is where we set up everything at the beginning of our game. So if we come to init game then, you can see here we set up our game state, which goes into the playing then. But what I've also done is I have reset the player score, so it doesn't remember what the score was from the last game we played and just carry on from there. I've also then, so in our do play game function, remember this is the main tick function we use when we're playing the game, I've added a new little function at the bottom of our draw section which is going to draw the game info. So at the moment we've got our scores going to come up in the top left corner, but eventually we're going to have player lives and so on coming up in maybe the top right corner. So I've sectioned that off then into its own little function. And again, really that's what you should be doing. At any time you are doing a different task, it should be in its own little function. So you can see here our draw is going through drawing our player ship and asteroids and bullets, and then going off and drawing our game screen. So if we come down here for the game info, it's going to use this print statement. And we're going to use a little bit different on the print statement, because the effect I want to achieve in here, if I actually run this and press Z, if you look in the top corner here, I'm having the word score printed out in yellow and then my actual score printed out in green. So I need to actually put two print statements together there, but have them align correctly horizontally. So if I come back to my code, we have a print statement. And I could actually, if I go across to the wiki page, and if I come down to print, the print function, what we'll see here is the print function then, it accepts the text, the coordinates, and a color. Okay, so I can change the color of my text. Fixed size font is default to false, and leave that at false. Scale then, we can have, that's got to be an integer value, so I can have scale 1 size text, which is normal size. I can double it or whatever. And then I can specify remember there's two sizes of font we use in the TIC80. We've got the small sized font and the large sized font. But what happens is when I do a print, if I want to, I can have that return back the pixel width of the text it just printed. And that's what I'm doing in my code here. I want to print out score, space, and I want to have my actual score being printed out next to that. So I need to know how many pixels were used up in printing this word score. So what I'm doing is I'm creating a little local variable to catch that information. I'm then doing my print statement, but I'm catching the pixel width it sends back with my local variable. What I can then do is do the second print statement, where I'm printing out the player's score. The x coordinate then is going to be the width that I got back from my first print statement. Okay, my y coordinate is still going to be 0, and I can now print it in a different color. So again, 14 is my yellow and 11 is my green. And that then gives me my draw game info function, where I'm piecing together different colored pieces of text. And again, if I run that and come out here, we can see then that we now have both our score coming up and obviously then our explosion effects. So that's got a lot of our asteroid functionality in place then. Really the main thing that we haven't got yet is that our asteroids don't actually hit our player ship. So that's what we'll cover in the next lesson. We'll look at polygon collision detection, which is a little bit more complicated. But having said that, we've actually written almost all of the code already. So make sure you save your work, and I look forward to seeing you in the next lesson. So have fun coding. Don't forget to visit the course pages for this project. There you'll be able to download the code for this lesson and get lots of extra hints and tips. You'll also get access to all my other programming, electronics and gaming projects. All the links are in the description below. For more games programming, electronics projects and retro gaming, please make sure you like this video, subscribe to my YouTube channel and visit my website.